Today we're going to talk about normalization. And normalization is a branch of database design and theoretical theory that helps us create a better design of our database. And the main purpose of normalization is going through the diagram that you have, the ER diagram, entity relationship diagram, and determining how much redundancy exists in a table. So our purpose from normalization is to make sure that we reduce the redundancy that exists. And throughout the process of doing that, we end up usually breaking up a table into multiple other tables so that we avoid the redundancy and we avoid unnecessary functional dependencies like we saw. So in the last video, we saw different types of functional dependencies, partial dependencies. So we want to avoid those because those cause anomalies. And so the goals of normalization, again, are to make sure that we reduce the level of redundancy. When we're doing normalization, we're going to find that there are several steps to normalization. And at every step, we are characterizing how much redundancy we have in that current schema. And we are doing that in through a known process where we have a mechanism for transforming schemas in order to remove those redundancies. So when we're talking about normalizations, we're going to talk about like first step, second step, third step, and each one of those is reducing the redundancy in a certain way. Now, there are 6 normal forms, but we are not going to cover all of these. We are only going to cover the first, second, and third normal form. The book talks about a 4th normal form, but we are not going to be talking about it in class. And with every normal form, we are getting closer to a better design, and we are getting closer to having no anomalies. And so the higher the normal form, the less redundancy that we have, and the less anomalies we are going to have. And so, like I said, we're going to talk about the first, second, and third normal form. The book talks about the Boyce-Codd normal form, but we are not going to be covering it. So let's start with first normal form. The purpose of first normal form is that we want to make sure that in our tables, no cell has multiple entities, multiple items in it. So remember we said that every cell needs to be atomic. And so if I give you a table like this and we have here a cell that is not atomic, like I have a color that's red and green, or I have a student that has many classes, we say that this cell is non-atomic. And so it is not in first normal form. So the purpose of first normal form is to make sure every cell is atomic. In other words, we can also say that there are no repeating groups. So in first normal form, what we want to do is make sure that at the intersection of every row and column, only single values are there and we have no repeating groups. So let's look at this table. I don't have a single value here. So what should I do? Well, first normal form says if you have a table like this, that means this column needs to be split into, this cell needs to be split into 2 rows that have the different colors. So what I would do is I would split here this table. Let me try to draw it out for you because this here in the slides is done in 2 steps. So the first thing I would need to do is to come and say, okay, I need to split my data so that I have product ID 1, red, and it's $15.99. And then I have 1, which is green, and it's $15.99. And then 2 is fine, it's yellow at $23.99. 3 is fine, it's green, and it's $17.50. Product 4, we have yellow from it for $9.99. Oops. And let's do a little bit more. And from it, we have also 4, that is blue, for $9.99. And then we have product 5, which is red, for $29.99. Okay, so that's the first thing you do. What you do is you take the cell that had multiple items in it and you split it into different rows. So now I have a table that has my product ID, the color of it, and the price. Now this table, of course, now is not going to work because now I don't have like the product ID, which used to be like the primary key. Now I have two rows that have the same primary key. So I ask myself, having it in one table is not going to work. What information should be kept together? Well, here I see that product ID 1 always has the price of $15.99. Red and green are the options for the colors. So I should really be storing the product ID and the price in a separate table so that I don't have this redundancy. So here I'll say that product ID 1 is $15.99, product ID 2 is $23.99, product 3 is $17.50, and so on. Okay, now this will give me the price information, but I also want to see what colors are available. So I need to store the colors in a different table. So I can say that I have one red and I can have one green. Now I have two yellow, and I'm just going to go on and I'm going to go to 4. 4, there's yellow from it, and 4, there's blue from it, and so on. If I look at the first table, if I use the ID as the primary key, that'll work because the key here is unique, the ID is unique, and the ID tells me the price. If I have to change the price, I'm changing it only in one place. If I have product 3 changed its price to $20, I only change it now in one place instead of having it to change it in multiple places. Now in the second table, I can't have the ID be the primary because there are duplicates. So I can have a composite key where the ID and the color together can be the primary key. So this is an example of a table that was not in first normal form. And to make it in first normal form, what I wanted to do was get rid of the repeating groups. When I got rid of the repeating groups and added those extra rows, I had duplicate information. I had the price duplicated. And I don't want that, so what I did was I said the price can go in a table by itself and the color can go in a table by itself. So this is an example of a table that went to first normal form. Okay, let's look at another example. So here I have a table and it has the student ID, name, the year, the semester they're in, kind of what they're studying. The unit code is what they're studying, kind of like a course, and the unit name, the name for the course. Now, here I don't have any cells that have repeating groups, so I don't have a cell that has two things in it. However, here I am told that the student ID is supposed to be the primary key, and I have two rows here that have the same primary key. Actually, I have 3 rows here that have the same primary key. And here I have 2 rows that have the same primary key. So those would be considered repeating groups. I'm repeating the student ID, student name, the year, and the semester just to say that this student is taking 3 different classes. So this is another example where you would have a table that is not in first normal form. And our goal is to move it to be in first normal form. So what should we do? What we want to do is we want to split this table so that the information that's repeated is stored only one time and any extra information is stored in a separate table. So here the information that is stored multiple times is the student ID, name, year, and semester. So this should go in a table by itself. The student ID, student name, year, and semester. And so now instead of having 1, 2, 3, 4, 5, 6 in this table, I move to a table that only has 3 rows because those are the 3 unique students that I have. Now, after I do that, I don't want to lose the courses that they are taking. So I need to make sure that for every student, I list the courses that they're taking. Here, the student ID is the primary key, so I can use that here also in my second table. Now, if I take the student ID and put it here, and then take the unit code that they are studying and the name of the class so that I don't lose any information, I look and I have now that student ID is listed many times. And because it's listed many times, it cannot be the primary key. So I ask myself, should I introduce a new column to be the primary key, or can I use a composite key? And so here we are going to use a composite key to identify a unique row. So if I have the student ID and the unit code, the class course that they have, that will be a unique combination to uniquely identify each row. So here again, we took a table that was not in first normal form, and we realized that we have repeating groups. And so I said, I need to remove those repeating groups by taking all the data that is common into one table, and then the data that differs, I'm going to put that in a different table. So this is how we would move one table from being unorganized to first normal form. Now, is first normal form like the end of everything and it solves the whole problem of anomalies? It doesn't, unfortunately. So here's the table, the second table that we created. This is the second table. I'm just putting it on the slide here. And if I look at this table, it's still not perfect. I look here and I see the unit code 783, for example, where it's advanced database. I'm storing this information more than one time. So first normal form is just a step towards a good non-redundant database, but it's not the final step. So if I think about the anomalies, are there any insert, update, or deletion anomalies that could occur with first normal form? Well, with insertion, let's say I insert a new course. Let's say I want to insert a course that I'm introducing for the first time. Here, to insert a course, part of the primary key is the student ID. That means I cannot introduce a new course without having a student registered in that class. So you want to introduce a course, you need to make sure a student registers for it first. That's not going to work. An update anomaly can happen here if I decide to change the unit name. So instead of advanced database, I want to make it advanced database with a D. If I change it in one place, now I have to change it in two places, more than one place. So update anomaly still exists. If I update in one place, I need to update in another place. Otherwise, I'm going to end up with two courses that have different names. Now, with the deletion also, if I have a student that I take out, let's say, the project, I don't have any students registered for the course for the project, I take that last student out. The information that stores the unit code and the unit name association will go away. So with first normal form, we still have insert anomaly, update anomaly, and delete anomaly.